Hi students, how are you? I hope you are quite fine, happy, healthy, and I hope your study is going on very fine. Students, this is lecture number of 12, total lecture number of 12, but chemical properties lecture number 3rd of aldehydes and ketone. And today we are going to discuss the addition of alcohol with that carbonyl compounds, means that is a nucleophilic addition. So nucleophilic additions of alcohols in carbonyl compounds. So there is the chemical properties here. We uh, we write here that the addition of alcohol in carbonyl compounds, correct? So that is the additions of addition of alcohol in carbonyl compounds. Okay, students. So when the carbonyl compounds add with the alcohol, three things will happen: hemiacetals, formation of hemiacetal, formation of acetal, and formation of ketals. One by one, we understand the how it will be the hemiacetals, acetals, or ketals. Let's understand first hemiacetal formation. Let me tell you, students, this whole process is the reversible reaction, reversible process, the reversible equilibrium, and equilibrium process. You can say that, and it is reversible. And this is the mechanism is nucleophilic additions mechanism. So see the simple reactions here. Anything you take the aldehyde or ketones. Hemiacetal means hemiacetal means one carbon if contains the OH and OR, both both group OH and OR group both attach on the one carbon, that is the hemiacetals. So what happens when we take that alcohol in the presence of dry HCl? What will take dry HCl strength. So when we'll take the dry HCl, alcohol in the dry HCl, what will happen? It will form COH, R, and here is the O negative. And the form that intermolecular hydride transfer here, and it will come here, COR and OH will form. This is the hemiacetals. So when one alcohols will take in a small amount of dry HCl or anhydrous HCl or gaseous HCl, the hemiacetal will form, correct? And if two moles alcohol will take, that the acetals will form. But what will happen when the excess of alcohol will use? See, when we'll take the excess of alcohol, what will happen? We understand so by two mechanisms. One is acid catalyzed. Second is base catalyzed mechanism. Correct. So first we understand the acid catalyzed mechanism. What will happen? C double bond O. See that what will happen? We take the alcohols. We are taking alcohols. Student, alcohol ROH is there. So alcohol react with the HCl and form the protonated alcohols ROH and H, which is called protonated alcohols. And these protonated alcohols then attack on means here is a lone pair on the carbonyl compounds oxygen's group. So OH, RH, and this oxygen will attack on the H plus ions, and what will happen? And then it is completely reversible stream. So keep in mind. So ROH, that is this carbonyl is too much electrophilic now. So the purpose of acid is to make the carbonyl compound too much electrophilic. So now we have the OH R, this alcohol will attack on the carbon and here bond will break like that. So what will form? Then it will form like the O, H, R and OH. Now student, second moles when we'll take the ROH, what will happen? Here is a lone pair of alcohols that will attract these protons and that will completely form the OR and OH. This is the hemiacetals formation. So did you understand why we have taken the OH and when we take the excess of OH, then what will happen? How hemiacetals will form? Now we talk about the in base catalyzed. In base catalyzed, what happened? Students, R, OH, and the base catalyzed means first you bring this alcohol as a base. So when we make the alcohol as a base, when dissolved in water, it forms the RO negative plus H3O plus hydronium ions. Or in any way, you can form the alkoxide ions as a nucleophile. And now this is a strong base, a strong nucleophile. Now, a strong nucleophile attack on the carbonyl compound directly. I have already taught in the concept of carbonyl compound mechanism. So if you see that mechanism, if you watch this mechanism, then nothing will happen, no problem will happen in the rest of that chemical properties. So what happened? O, here is that negative charge and R that will attack on this compound and directly. So what will happen? It will form that C, O and OR, and here is the O negative. Now again, alcohol will take that here, and now it is a highly basic substances, so it will attack this proton, and what will happen is then that will form the COR and OH. Now again, the same process we will repeat here. We'll take that HOHR, just like remember that here we have taken that protons. First we make the alcohol as a protonated alcohol. So once the protonated alcohol is formed, then again it will attract this proton, and then that will form like that COR, OH and H cations, and that substances will break like that. COR and cations will form. Correct. Now again, what will happen? We'll take the ROH alcohol. Now that will attack here, and it will form. Before that, I would like to tell you one thing. Here is that lone pair is there. Lone pair is there. That lone pair will come here and COR positive charge here, and double bond will form. Correct. So now when we'll take the ROH, this bond will shift here. That will attack here, and COR OH ORH will form. That will release the protons. But how it will release the proton? When we take the alcohol, then it will happen. Otherwise, it's not possible. And then it will form the COR OR. That means acetals will form. Did you understand here? So just what I'm telling you, here is that you have got that here is the acetals. So here you got that acetals hemiacetals formations, hemiacetals formation, and after that when we go with that again we'll attack that formation of acetals is happening. Correct, student? But one thing is that very important. What I am telling you, uh, here is the basic medium. Through the base catalyzed, we can form the hemiacetals. But after hemiacetals, once the formation of hemiacetals, either the acid catalyzed or base catalyzed, then the acetal is formed by the acid catalyzed again. So again, I have used the acid catalyzed and the acetal is formed. So once you form the hemiacetals by acid catalyzed or base catalyzed, you can form the acetals by the acid catalyzed again. So same process we will use here exactly, which we have done here. So by the base catalyzed, what we have done? By the base catalyzed, we have formed the hemiacetals, right? And by the acid catalyzed, we have formed the hemiacetal. So once the hemiacetal is formed, you can take the again alcohols. and then they form the acetals is here. So one thing is keep in mind, students, acetals is formations always when you take the excess of alcohol, you can form the acetals. That means the reaction will move in the forward direction. As you know, earlier I said, acetals or hemicetls, both formation are reversible process. And second, that when you take the excess of alcohols, that will move in the forward direction, the formation of acetals. Now, one thing keep in mind, either in any way you form the acetals, OR and OR. So when you take the water, H3O plus, right, that is the reversible process. So what happened? In the acidic mediums, that will form the OH and OH plus 2 moles of ROH. So one thing keep in mind, student, when the 2H group on the same carbon, that will be formed, the water is removed, dehydration will happen, and the carbonyl compound is formed. So when the acetals you have given, that will uh, that will convert back into the aldehyde or ketone by the, if you take the water in the acidic mediums, or if you hydrolyze, that form the ketones or aldehydes, correct? Or if you take the dilute HCl, that will means when you take the acid dilute HCl or hydrolyzed, that will form the ketones group or aldehyde groups, correct? And now the most important things is here, students, what I am telling you. See here that the formation of ketals, how to form the ketals. Third is, third we have, first we have done the hemicetals, second we have done the acetals, third we are going to understand the ketals. Still, ketals means when aldehyde and ketones react with ethylene glycol to form the stable compound, which is called ketals. So either you take the aldehyde or ketone, which will react with the OHCH2 and the CH2OH, correct? In the acidic medium, H plus means I'm saying that dilute dry HCl or gaseous HCl. So that HCl is that what? Dry or gaseous HCl or anhydrous HCl. And when we take the dilute HCl, that will convert back into the reversible. So OH2 is removed here, and the carbonyl compound COCH2 and OCH2 will form. That is called ethylene glycol ketal. It is what? Ethylene glycol ketals will form. Now, they understand the how it will be happen. See, first we have taken the dilute HCl. So either you make the protonated alcohol, or you make the directly attack on the carbonyl compound and form the more electrophilic. So when we take the H plus ions, that will attack on this oxygen attack on the protons, and it form the OH plus. That means the highly electrophilic carbonyl compound now becomes highly electrophilic. Now these highly electrophilic compounds, when you take the alcohols group like that, what will happen? That lone pair that will move here because it is highly electrophilic, and the carbonyl center here, it will come to the center, and it will form the like that O. There is the OH and OH CH2 CH2 OH group like that, and there is a positive charge, so it will move here, and compound is like O CH2 CH2OH, and here is the OH. Again, you take that dilute HCl, dry HCl, so H plus again will attack here, and Simon, what will happen? CO CH2 CH2OH, and once the H will form, cations will come, and then again the C cations, OCH2 CH2OH will form here, and as you know, there is a positive charge here. So now the oxygen will attack on this positive center, and it will form the OCH2 CH2O, and here is the H. Positive charge again come here, and then the compound will form like that COCH2 CH2O like that. This is the called ketals formation. Student, once let me tell you the ketals, when the dilute HCl, you take the dilute HCl, that what will happen? Here the bond will break, H and OH, H and OH will come will come here, and then the OH and OH plus CH2OH and CH2OH will form. Now once the OH group attach on the same positions, so that it will supply, it will be it becomes unstable, and the compound water will lose and then form like that C double bond. So it will back convert into that carbonyl group when you will take that valued HCl like that. So in the presence of base, it is highly stable. So if you take the in the ketals in the base, when any base you take, the reaction will not be happens. What I'm telling you, suppose suppose you have the compound like that. Here is that double bond CO CH2 OCH2, and if you take the R base like that OH minus, no, nothing will happen. No reaction will happen in the presence of base. So keep in mind, any base you will take, the reaction will not be happen. When you take any base, reaction will not be happen. So it is highly stable in the presence of base. Okay. Okay. Students, I hope you understood. Let's understand the 1 and 2 questions, which will help you to understand the whole concept. See, the questions is here. Okay. Here is the compound like that OH. Just you try to solve this compounds. CH2. I have taken the H3O plus. What do you think? What product will form? I give the option. A is that the compound like that OH, OH, OH. B option is SCHO, and C is that the compound will form like that OH, 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 and D is A and B both. What do you think? Just to think about this these questions and tell me what the answer will be. H3O plus acid I have taken. Students, again I repeat, if you take the base, reaction will not be happen. Since you have taken the acid, so what happened? Here is the H, here is the H will form, and here is the OH, and OH will form. So what will happen? The complete reaction will be the OH, OH, and OH plus. Here is the CH2, OH, OH. That means that what will happen? HCHO is formed. So one is this product is formed, and second is here, and so A and B. That means your options D is correct. So I hope you understood the whole concept. Correct? Now, students, what I am telling you. Now, next questions just to understand what will happen. See here. Second question is, you have given here O, O, and this compound, right? And C, O, O, CH2, correct? And here is that this compound is the reaction. Now H plus you have taken, so A and B what will form? Now I give you the option A. So here is that O, C, this compound, B, tell me what will happen? CH3, double bond O, C, O form, and C is that C, O, O, and here is that OH, and D, C, O, O, and O, OH will form. What do you think? What option is correct? Just to think about these questions, and just think about this question and tell me what option is correct. Your option is this. Here is given the option. Just to think about it. Put the hold and try to solve the questions. Okay. See, students, I have taken the acid. So obviously here is the here is the OH, and H will come. OH and H will come. So ultimately, what is going to be happening here? That will form like that C, O. Oh, sorry, option questions I have written wrong. Here is that. Let me write the correct questions. CHO. No, that's correct. Now that's correct. So what is going to be formed here? Here is that. Is that C, CHO, and here is that OH. OH will form. Along with that, there is the one carbon and one carbon. So CH2 OH, CH2, OH will form. So what is going to be formed? This compounds. It is a here is a CHO double bond O will form. Correct. Now this compound is that aldehyde and ketones. As you know, the carbon compound is more reactive with the aldehyde. So now OHCH2 and HOCH2. So O is removed and the compound is going to be formed like that. COCH2, OCH2, correct? Double bond O. So this compound is formed. So which option is going to be correct here? Just to check that your second option is going to be correct. Okay. So I hope you understood that how to form the hemicetls, acetals, and ketal formations. Students, once you understand it, please like, share, and subscribe the channel. Thank you so much. Have a nice day.